Okay, 1.5, solving inequalities. We're going to solve each inequality and graph the solution set. We will go back to those two multiple choice questions above later. Alright, so if we're trying to solve, that just means get the letter by itself. So in number 3, we want to go ahead and add 6 to both sides. So 8x would be greater than or equal to 16. To get x by itself, we'll divide by 8. So x will be greater than or equal to 2. Simple enough. Well, when we're doing inequalities, we'll also graph them. The difference between an inequality and an equation is in an equation, you typically get one answer. In an inequality, you're going to have multiple answers that would work for this problem. So in our answer, it says x is greater than or equal to 2. So it says that 2 will work. So 8 times 2, 16 minus 6, it's 10, is greater than or equal to 10. Yes, because it's equal to 10. But if you plugged 3 in, it would also work. So 24 minus 6 is 18. That's bigger than 10. Well, if 3 works, 4 works, 5 works, 6 works, and all the decimals in between those work. So you have multiple answers, usually with a starting point. So the starting point of our answers is at 2. So if we're going to graph this, I like nice simple graphs, so I just draw a line. I generally like to have 0 on there. So I'm going to stick my 0 right here, and then a 1 and a 2. And I don't even label all of the little dashes that I make. Now if we want to include 2, then we can put a closed circle. So I color it in. And then since I always put my letter on the left, this says that you're going to shade whatever way this points. So some people make mistakes with their shading. If your letter's on the left, you'll never make that mistake. It'll say shade bigger. So I just use a squiggly line and then kind of darken in my arrow. Instead of scratching on there, you don't need to make a big mess. We'll just make a nice little squiggly line. And especially if you use two colors, it's real easy to see that the red is the solution part. Alright, so easy enough. Should be a review with solving some inequalities. So number 4 here, in order to get the letter by itself, we first would need to distribute. So we'll have negative 12w plus 3 is greater than 3w minus 15. Now I like my letters on the left, so I'm going to subtract 3w. Negative 15w plus 3 is greater than negative 15. Subtract my 3. Negative 15w is greater than negative 18. Well, it doesn't come out so nice, but we can still do the problem. Now, note, when you multiply or divide by a negative, you have to switch the sign. But you might remember that from Algebra 1 when you did these. So we're going to make this be a less than sign. Now can we reduce 18/15? Both of them are divisible by 3, so that's going to be 6/5. Well, again, we want to graph that. Just because it's a fraction doesn't mean anything to us. Not a big deal. 6/5 is 1 1/5. So it's a little bit bigger than 1. So I'm going to go 0, 1, 2. Now 1 1/5, I would say, is right about here. Now I'm going to use an open circle because it doesn't have the little equal to sign. So that is actually not an answer. 1 1/5 would not work in this problem, but everything less than it would. So all these numbers right up to it and less than it would work. So we need to graph that, and so there is your solution. So it's okay if you get fraction answers. Don't panic. I just like to see in between what two whole numbers are they. You don't even have to mark 1 1/5 on your graph if you don't want to. So those are just a review on solving inequalities. So why are we doing this in Algebra 2? Well, we will increase our knowledge here now. We will now have what we call compound inequalities. So these will be compound inequalities. And what that means is that there's either an and or an or. And we'll come back over here and make some notes for and ors and see how we can memorize what goes with what. Alright, so number 5, it kind of looks like we have two separate problems. 4x plus 2 is greater than negative 6, and x minus 5 is less than 8. So what you want to do here is just like with your equal sign, you want to keep this separated. So I'm going to separate it with that line. And I'm going to solve them individually. So here we would subtract 2, so 4x is greater than negative 8. I'm going to divide by 4, which is positive, so I won't switch the sign. So x is greater than negative 2. So numbers like negative 1, 0, 1, 2, 3, 4, all of those are working for that side. Okay? Now over here on this side, if we add 5, we're just going to get x is less than 13. Now there's an and between these two. So you have to think about it. I want all the numbers that are bigger than negative 2. Negative 1, 0, 1, 2, 3, 4, 5. But at the same time, because it's an and, they have to be smaller than 13. So if we are going to graph this solution, put 0 on here, negative 2, and 13. I want my numbers to be bigger than negative 2, so I'm going to put an open circle on negative 2, and I'm thinking about all these numbers. These are all bigger than negative 2. But when you get over here to this orange one, it needs to be less than 13. So I can't pass 13. 13 would also get an open circle because it's not included. So to me, that says between. So over here under and, I'm going to think about between as an important word for an and graph. Ands are usually in between. So this is a very typical and graph between two numbers. So it's like the inside of the graph. Okay? If you have an and problem, it's possible to get no solution. For example, if I said that these numbers were greater than 2 and less than 0. Okay? If we said x is greater than 2 and x is less than 0. Can you find any number that works there? Well, greater than 2 is 3, 4, 5, 6, 7. Less than 0 are the negative numbers. None of those would work because they have to work in both situations because it's an and. Okay? Another little thing about and problems is that you'll always want to write your solution as between. So once you get this graph set up, you're going to want to set up your solution to look like this. And that's how a typical and problem would look. Now if you look at this over here, x is greater than negative 2. The little arrow is pointing at the negative 2. Well, in our problem, our arrow is also pointing at the negative 2. The arrow's pointing away from the 13. And over here in our answer, it's also pointing away from the 13. This is how they like their and answers written, as a between two numbers. Okay, so when you're doing ands, you should be thinking between all the time. All right, so then what is an or problem? Same thing. We just want to remember it's or. So we're going to solve these. 3x is greater than 12. X is greater than 4. Or x will be, we're going to subtract 6, less than negative 13. Now for an or problem, you're not trying to be between two things. Okay? For an or problem, that means all solutions that work. So anything that works for this answer or anything that works for this answer is good enough. It doesn't have to work in both of them. That would be an and problem. So if we're going to graph this, I want to be greater than 4. So I'll put 0 on here. I'm going to put 4 here. Open circle, greater than 4. So all those numbers work. 5, 6, 7, 8, 9, 10, and all the decimals between them. Or negative 13 is down here. So open circle, go down from 13. Now that's a very typical or graph. I like to think of that as the ends of the graph. It is possible to get all real solutions. It is not possible to get no solution for an OR problem.